Assalamualaikum warahmatullahi wabarakatuh. My name is Tengku Muhammad Aiman bin Tengku Juhari. I am from BMMP. Today I want to present my bachelor degree project. The title is Effect of Current Density and Filling Time on the FPC Microblind via Filling Formation. My supervisor is Professor Madya TS Dr. Lau Kok T. Okay, this is my presentation outline. First is introduction. Second is literature review. Third is methodology. Fourth is result and discussion. And lastly is conclusion. Okay, for the introduction, electronic packaging technology plays an important role in improving the performance of electronic products through the development of microelectronic devices. Before that, FPC stands for Flexible Printed Circuit. A better definition of FPC would be the perfect solution to your electronic packaging needs. Flexible circuits have evolved and help provide durability and reliability. As shown in the figure, that is the type of flexible printed circuit. Microfilling by copper electroplating may be used to bind two or more layers of flexible printed circuit adjacent to each. The microvia must be completely filled by seamless or seamless copper via filling in an acidic copper plating solution containing different main additives to ensure that is effective electrical interconnection. There are two problem statements, which are the electroplate filling microblind via will overplating and underplating. Next, this condition will lead to the formation of the surface dimple and bump on the filled microvia. During the electroplating filling process, if the parameters used are not in optimal level, the electroplate microblind via filling will overplating and underplating. Due to tight tolerance factor, the bump make it difficult to add a new layer to the overfilled microvia. In the meantime, the seam and the dimple that result in the gap between of the FPC will affect the quality of the FPC. Okay, as shown in the figure, there is a void in the via, and there is the dimple in the via. Okay, there are three objectives of the project. First is to perform an experiment of copper via filling. Before perform the experiment, we need to study about the filling parameter of the copper via filling. Second objective is to study the effect of current density on the FPC microblind via filling formation. The result can be via ratio, nipple depth, and surface layer thickness. Third objective is to investigate the effect of filling time on the FPC microblind via filling formation. The result also can be via ratio, nipple depth, and surface layer thickness. To study the effect, we need to do the testing. Okay, this is the scope of the project. This study will focus on the measure and analysis effect of current density and filling time of FPC microblind via filling formation. To develop the research, an experiment was performed by cutting the via of the FPC into some pieces. Then, An electrolyte system consists of sulfuric acid, copper sulfate, pentahydrate, suppressor, brightener, and correction was used to perform the copper electroplating process. The filling time was set and the current density was set. The FPC was set as a cathode and the copper sheet was set as an anode. To analyze the effect of controllable parameter to the microblind via filling, the fill via were cut out from the FPC after the filling process. Then, an acrylic resin and surface grinding, also the polishing machine were employed in order to gain the cross-section of the fill via. Furthermore, an optical microscope with a magnification of 50x and 100x was used to observe the properties of the fill via, include the surface thickness, dimple depth, and filling ratio. Literature review. First is authored by Feng in 2014. The title is the electroplate copper filling of through holes on varying substrate thickness. The summary is higher cavities can produce reliability and decrease the capacity of lines. Next is authored by Wang in 2017. The title is Parameter Analysis on the Ultrasonic TSV Filling Process and Electrochemical Character. The summary is the higher the current density, the lower the void formed in the via. Methodology. The detailed methodology helps to archive the basic methodological measure or process for achieving the goals of this blind macro via on the flexible printed circuit. The methodology used for the overall research work, raw material and testing procedure will be explained. Okay, based on the flowchart of this project illustrate, it shown the first step of the research is start searching the journal or article to gather all information about the microblind via filling. Second, the flowchart will be proceed to a data collection, whereas all the data collection are emphasized to two requirements, which are defined experiment parameter and preparation of material. Besides, the research project will be continued through the run electroplating process until the process is successfully done. In the decision box, the data will be analyzed. If the result is good, the analysis will proceed to the second fabrication sample. After fabrication sample, the sample will be testing using optical microscope to define the experiment result. Also, the objective of the experiment, which is via ratio, surface layer thickness, and dimple depth. The sample may undergo the data analysis. If the result is good, the analyzed data will be proceed. Lastly, the research will be end up by writing report. In this study, MFS technology has provided 4 pieces. Multilayer FPC with a total thickness of 100 micron as shown in the figure. To study the properties of the FPC board need to be cut into some pieces because the via need to perform the electroplating process and the cross-section sample. Before cut the FPC, define the via of the FPC first. Then, measure the FPC area that need to cut. The FPC via was cut using a cutter or use a better quality cutter blade. Since it is copper, cheap cutter will become dull very fast. This is the preparation of the electrolyte. In this study, MFS technology has provided an electrolyte system for copper via filling process. The electrolyte system of acid copper include copper sulfate pentahydrate, sulfuric acid, hydrochloric acid, and organic additive like correction, suppressor, brightener. In the electrolyte system, the acid and additive need to be mixed together to perform a mixture that's called an electrolyte system. In addition, Attach Malaysia Sdn Bhd manufactures an electrolyte system for copper via filling process, as shown in the table. Based on the figure, measure the volume of acid and additive, then the acid and additive will be mixed together as shown in the figure. The mixture do not mix completely because it needs to be stirred using magnetic stirrer or using spatula in a specific time. Set the time and stir the mixture to perform an electrolyte system. This is the preparation of the workpiece material. The preparation of the copper sheet is used in this process to make as an electrode used in the electroplating process. This copper was cut into some pieces using a scissor. This is the schematic diagram and actual electroplating process. As shown in the figure, the schematic diagram of copper via filling process that consists of three subsystems which are mechanical, electrical, and chemical. The electrical component is central to the functioning of the filling system, while in the chemical aspect, it is about the concentration and the composition of the electrolyte solution. And for the mechanical part, also central to the quality process of copper via fill. The mechanical component consists of a sparger nozzle, FPC holder, a pump, and filter. Currently, there are about 3 types of additive offered in the industry are brightener, suppressor, and leveler. Brightener is a valuable chemical due to its real-world enhancing capabilities, while suppressor can act as the deposition suppressor in the process, absorbing the wall deposition area, making the slow deposition area. However, the leveler stop at surface and at the opening of the via to prevent closing of the via until the via is fully filled. Current density is defined as the amount of charge per unit time that flow through a unit area of a chosen cross section. In SI-based unit, the electric current density is measured in amperes per square meter. Current density is yet another factor influencing copper plating. Samples under various current density are also discussed. As current density increases, crowding at exit wall may increase. Current density was calculated by using equation as shown in the slide. Time of filling rate is defined as the amount of time taken for copper via filling process. Filling time is another factor influencing copper electroplating. Samples under various filling time are also discussed. The filling time was set with 40 minutes, 60 minutes, and also 80 minutes to the copper via filling process. For the measurement and analysis, in this research, there are several steps which are the measurement and analysis we will explain thoroughly in this session. For the sample cross-section fabrication, to obtain a cross-section of the field, a pipe PVC will cut into some pieces. The function of cut the PVC pipe is as a mold. put the cut fill via of the FPC in the mold and then clip the FPC with a paper clip, so the position of the FPC will be upright. Mix the resin and the hardener so the mixture will make the resin dry quickly. Before put the resin into the mold, apply some Vaseline at the wall of the mold so the resin can be easily removed from the mold. Then the mold was filled by mixture of an acrylic resin and hardener. The sample after electroplating process. This is the result of the current density and filling time to the surface thickness. As you can see here, if the current density and filling time increase, the average of surface thickness also increase. So the deposition rate of copper ion will fill the via also higher. Furthermore, this is the result of the current density and filling time to the dimple depth. As we can see here, as the current density and filling time increase, the dimple depth will decrease because the copper deposition rate causing a reduction in the filling depth. Okay, the result of the current density and filling time to the via ratio. As the current density and filling time increase, the average via filling ratio will also increase because this is causing copper ion to accept the charge and deposit to the FPC. Okay, as a conclusion, this study describes a copper electroplating enabling technology for filling microvia. In a nutshell, this experiment of the copper via filling have been performed successfully. The study also contributes the basic knowledge of the current density and on copper via filling to the filling behavior of copper filled microvia. Furthermore, this study analyzes about the effect of filling time to the filling behavior. After perform the copper via filling process and study about the effect of parameter for the surface thickness, as the filling time and current density increase, the surface thickness also increase. While for the dimple depth, as the filling time and current density increase, the dimple depth will decrease. And lastly, for the via filling ratio, as the filling time increase and current density increase, the via filling ratio also increase because more deposit copper ion enter the via. Okay, further analysis is need to better understand the effect of various anode material and structure on the filling behavior of copper microvia. That's all from me. Thank you.